Hey everyone, my name is Thomas, and today I'm going to be showcasing how to deploy a LangChain agent on AWS using serverless architecture. And if you haven't seen my prior videos about this create agent and what LangChain v1 looks like, I do advocate for you to do so. And I am also an AWS community builder, so this is right up my alley, specifically for the serverless category. All right, so let's start in the serverless LangChain agent repository. By the way, the link to this will be in the description, and you can go at your own pace. The purposes of this video is just to showcase the file structure and what I'm using here. In addition, I'll issue some HTTP requests just to showcase what it looks like. So let's start with the pyproject.toml, and in particular, the dependency section. I just want to go over each one of these and give a high level of why they're here. So first we have the AWS CDK library. That's going to be my infrastructure as code choice. I could have used something like Terraform, but this one is really easy enough, especially for what I'm doing. I'm leveraging Bodo 3 just to pull runtime secrets using the SSM Parameter Store. I'm using FastAPI as the HTTP server of choice. You could have chose anything. I'm using LangChain and specifying an extra of OpenAI because they'll automatically have chat OpenAI instantiated underneath the hood for me. I'm also going to be leveraging LangGraph DynamoDB Checkpoint. This is an open source library where instead of using something like Postgres or in-memory saver, you can persist your memory or chats or messages, LangGraph updates, etc. to in particular DynamoDB table. It was actually really nice to use. I have not used this in production myself, but it seemingly is okay so far. I'm also using UVcorn. I want to touch on some of the internal developer tooling as well. So I used Pyrefly as my LSP. I've used Pydantic in the past as well as MyPy, but I just want to give it a shot, see how good it felt. It's really fast. It's nice so far. Haven't had any complaints. I'm also using Po the Poet as my task runner within pyproject.toml, and I'll showcase to you some of those tasks. And I'm using Rough as my linter and my formatter, because Rough, if you haven't used it yet, it replaces the need for things like Flake8, isort, Black, etc. And here are those tasks that I was talking about. So you'll see I have a lint, format, build, start, restart, etc. And I'll get into some of these and what they are in a second, or you can read the README at your own pace to understand. So the first thing I want to go over is this SSM Parameter Store secret. For those that know the chicken and the egg, you need to be able to create the secret first manually before your infrastructure as code can reference it. So that is what this script does. You export your OpenAI API key first, and it'll handle everything for you to set up the secret. I'll go ahead and run that script just to showcase to you the output. This will connect to my AWS environment and reset up that key. It's already been made for me previously because I've ran this before, but it'll just overwrite it. So let's first start at app.py underneath the infrastructure as code folder, or IAC as I called it. And we're going to look at the stack here. I'm not going to go into depth about the AWS CDK, but I am just going to highlight some of the components I'm using here. So first I grabbed that SSM string parameter because I want to reference it for the Lambda later. I go ahead and create the DynamoDB table, and I know this is the format that's necessary for the DynamoDB checkpoint library. Then I go ahead and create a Lambda using a Docker image. I have done other things in the past, like for example, in-house bundling. But if you use something like a Python Lambda function, it's a little bit more iffy in that regard. And if you know what I'm talking about, great, but just don't worry about it if you don't. I did have to specify AWS LWA invoke mode or Lambda Web Adapter. This allows both buffered and non-buffered, aka streaming. I gave it a max duration of 15 minutes just because I didn't want to mess with that. I didn't want to see a timeout, so I just gave it the most it could do. I gave the function read, and this is where I'm using that OpenAI API key SSM store earlier. This grant read is just a nice function that will automatically add to the role principal of the function. Same thing with the checkpoints table. I'm granting read-write data to the function. So what these two do underneath the hood is actually modify this underlying role and give that function access. Hopefully minimally viable, of course. And then I am using a Lambda function URL. There are other ways you can do this. AWS, for example, just released where you can hook up an API gateway to a Lambda now with streaming, but I'm just going to use the function URL because they didn't have support for that yet in the CDK. I also have just an output here to showcase as a nicety the URL just so I can have it right directly on the output. So now with all that being said, let's do uv run po deploy. And this will run CDK underneath the hood, which you'll need to install it, of course, and that's using npm. So I'm going to let this thing run, and we're just going to wait for it to give an output for the stack. Actually, while we're waiting on this, let's go ahead and peruse under the agent subfolder here. So I first want to start at the app.py. This is where we build the FastAPI server and where we include the router. I am using UVcorn to run this thing, and I'm using a lifespan async context manager. And what this does is grab the get OpenAPI or get OpenAI API key, and it uses this global because Lambdas, this is how you have like global variables or cache between invocations. I don't want to have to keep hitting SSM Parameter Store repeatedly, so I can just fetch it once, have it for the duration of however many warm starts there are, and I can just go with that. Because Boto 3 isn't async compatible, you do have to put it to this async IO to thread method, but it works the same, honestly. There's also the get agent dependency here. This does the checkpoints table name and then instantiates the agent. So if we go ahead and look at the agent, you'll see it's very simplistic. I'm not doing anything crazy here. I didn't give it any tools. Ideally, this is where you'd go wild and have a system prompt and or a human message here if you want to give it strict instructions. But for now, it's just create agent. I gave it the crappiest model I could find, and then I gave it that DynamoDB saver. And I gave it a TTL of 24 hours and seconds because I think the TTL was really low and I just didn't want it to expire as I'm making the tutorial. If you're going to use the DynamoDB saver apart from this project, just know that if you feed it a table name that doesn't exist, the author will go ahead and create the table. I wanted to manage it in infrastructure as code, not rely on SDK functionality like this. So just keep that in mind if you want to do this yourself. I have taken the liberty of creating a table with this key schema that is required for you all. Cool, and lastly, I just want to showcase the routes. Very simplistic. We have a health Z route, which just returns OK, just to make sure it's even live and running. We have a /chat, and all this chat does is it'll generate a conversation ID. It'll append the user message, which comes from the chat request, which is really just a message of type string, as well as an optional conversation ID. It'll grab the result after it invokes it. It'll grab the latest message from the result and then output that to us. And you'll notice that stream does a very similar thing, except I'm using this streaming response idea. And so if you look at generate stream, it uses the aStream method rather than the aInvoke. I'm using the aStream method just to showcase that it is possible here to get back LLM token stream to you. It's a very nice thing that LangChain just handles underneath the hood for you, specifically using LangGraph. And I would recommend using this in production. To prove that short-term memory or message history is actually being created here, I have this idea of conversation ID. Effectively, if you supply a conversation ID, it'll actually keep appending to a prior conversation. If you don't supply one, then it'll create one for you and you can continue with that UUID that you were given back. And I will showcase how that works. Cool, so it did finish deploying. Let's go ahead and grab the URL here. And let's go curl the URL as well as health Z. Let me hit enter. And yep, we got back status OK. So we know it is indeed working. One thing to note is that I did not add authentication or authorization for the purposes of this tutorial, but this will be something you'll want to add whenever you get there. So I've typed out the post request here. So I am going to be hitting the Lambda URL on the /chat endpoint with a content type of application JSON with just a simplistic message of what is the capital of France. And I'm hoping this comes back with Paris. All right, cool. So we got back a conversation ID. And the AI did say the capital of France is Paris. Now to prove that we can continue this conversation, let me go ahead and put in the conversation ID again here. And let me grab it from right here. And let me just put in a new message of what did I just ask? So I'm going to enter there. It says you asked what is the capital of France? So we can see that our chat is working. So this was our request before. To make it streamable, all you need to do is /stream and press enter. We'll see the first data chunk that was sent to us was the conversation ID. Then the subsequent ones were the capital of France is Paris, period, or all of these streamed tokens. And we can continue the conversation similarly as before. So let me do conversation _ID. And let me grab it from up here. So we're going to enter that here. We got back the same ID as before. You ask, comma, what is the capital of France? So we see that both streaming and buffered work. The final thing I wanted to cover about this is that you can run uv run po dev. And what this does is use the Docker Compose that is inside of this repository, and it will build the containers for you, and then watching will be enabled on them. So if I go inside the repository and change that status check, so let me go to routes, and instead of OK, let's put OK with an A and a Y. I'm going to Control save that. We see syncing service agent after 1 savings were detected. Let me go ahead and hit it. There you go. It automatically updated. And if you update any of the dependencies, it'll actually restart the entire container for you. Now, granted, this does mean that you do have to have active AWS credentials for it to sync. In particular, inside of the Docker Compose, you'll see that I tried to make this easy. I have where it'll be either mounted to your root or use your AWS access key, secret access key, and session tokens here. I also had to set the default region for the DynamoDB Saver class. One other point about the Docker is that I am using a target of development to get the hot reload functioning correctly. The Docker has actually 2 separate stages. You have development, which just runs UVcorn directly with the -- reload at the ending. And then for production, it actually just calls the agent app.py, which then if you look here, it does the UVcorn here as well, just without that hot reload. So hopefully you did all enjoy this tutorial, and I do hope you enjoy this template to at least get something going and starting out. Thank you everyone for watching. Please subscribe if you haven't, and hope to see you in the next one.